Brian, and I'm joined by my colleague Carsten in Germany. And today we're talking about virtual private networking with Kerio Control. For the agenda today, we'll start with just a general overview of VPN as a technology. Then we'll talk about some of the traditional challenges with virtual private networking. Then we'll talk about Kerio Control and how the VPN and Kerio Control overcomes a lot of those traditional VPN challenges. Carsten will do a demonstration, and then we'll open it up for Q&A at the end. And of course, you'll see on the right side there, you've got a Q&A section, so feel free to ask questions throughout the presentation. So before we get into virtual private networking, just a quick overview of Kerio Control for those of you that are unfamiliar. Unified threat management without complexity, so simplicity is certainly a common theme with all of our products. Network firewall, routing, and intrusion prevention is sort of the core of the security of Kerio Control. Transparent virus protection via Sophos is as well another security component of the UTM. And secure virtual private networking, which is the topic for today. There is web content filtering, so obviously making sure that people on your network are not going to websites they shouldn't be visiting. Quality of service, which is another component of a UTM, so making sure that you don't have individual users that are taking up more bandwidth that they should be, and that you can reserve bandwidth for necessary services such as voice over IP. And then flexible deployment, which is another common theme of all of our products, making sure that you can deploy Kerio Control, in this case, in a variety of different ways, whether it's a hardware appliance, software appliance, or a virtual appliance. So you've got many ways that you can deploy Kerio Control. And talking about hardware appliances, just real briefly here, we're excited about the release of the NG100, which is a new addition to our hardware lineup. You can see the image there. It's a very small form factor, very small box, designed mostly for kind of these smaller office environments, 10 or so odd users. However, it is still very powerful, as you'll see from the specifications there. It's a dual-core add-on at 1.3 gigahertz with 4 gigs of RAM, 32 gigs of storage on a very fast solid state, 3 network interfaces, all powered by an Intel controller, at a very reasonable price point, $625 or 544 euros. But the unique differentiator with this is the unlimited user license, which is something that's new to Kerio Control and to the hardware box. That's not an option we've traditionally made available. So that's a very intriguing and compelling option there to have an unlimited user license with that low of a price point. So now we'll talk about virtual private networking just as a general technology. This might be a refresher for many of you, as it's just kind of covering the basics of VPN. So the general definition, obviously from the Wikipedia, is that it's extending a private network over a public network, i.e. the internet. And the main enabling component there is that it allows users to remotely access resources over a private network. So if you've got a mobile workforce, they can log in remotely and still have full access to all the resources on the internal network. And the other scenario is site-to-site networking. So if you've got geographically separate networks, they can connect securely over the internet. And just to kind of recap those two access type scenarios, you've got remote access of a single device, whether it's a mobile device or a laptop, connecting over the internet securely to the remote private network. The other access type is a site-to-site network where you're securely tunneling to different geographically separate private networks. Benefits of virtual private networking, probably pretty straightforward for most of you, but for those that are somewhat new to VPN as a technology, the main benefit is that it's tunneling everything through, or all protocols through a single pipe, through a single connection. So you see from the illustration there, you've got multiple protocols all being tunneled or encapsulated through a single connection. So the main benefits of this type of architecture are that you don't have to open ports through the firewall or expose services So the alternative, of course, being that you do standard port mapping, which is a less secure way of doing things. The other benefit of tunneling all of the protocols through one connection is that applications tend to work better because you don't have to perform network address translation on that communication. Another benefit of virtual private networking is the fact that you're enforcing or requiring authentication so that you have an audit trail of the activities that people are doing when they're remotely accessing resources on your private networking. So you're ensuring that there is some authentication. And as well, you're also ensuring that all of the protocols are encrypted. So in the illustration above where you've got FTP, IMAP, SIP, those may not be encrypted protocols, but when they're tunneled through a VPN connection, you can be sure that they're all going to be encrypted so that you can avoid any potential of snooping or eavesdropping on an unencrypted type of connection. Standard network topologies, so there's basically two, the star type of network connection or hub and spoke where you've got one centrally managed VPN gateway and all of the other networks connect through that. So it's easier to manage, but it does introduce a single point of failure. It's also adding extra hops or latency so that if you want two devices to talk to each other, they have to go through a central server. So easier to manage, but does introduce some latency and having a single point of failure. The alternative, and probably the more common scenario, is a mesh type network where all of the VPN gateways have a specific tunnel to each other, as you can see from the diagram there. This is probably the preferred option because it's more reliable. You don't have a single point of failure, and it's faster access. So hosts don't have to route all of their connections through a single gateway. And this, of course, Kerio Control does support both of these scenarios. And again, the preferred would be the mesh type of connection. So another sort of concept of virtual private networking, or capability rather, is split tunneling. So the way this works is that, and it's generally applicable to remote VPN clients, so just a single user. And with split tunneling, what it means is that the remote device has access to the remote private network, but if it needs to access internet resources, it can do so directly. It does not have to route that connection through the VPN network. So this is sort of enabling for the user, but it's considered less secure because you don't have as many controls over the remote VPN client at the gateway level. So if you have content filtering policies, access policies, if you're doing split tunneling, those policies would not apply to remote devices. So, and this is of course an option in Kerio Control that Carsten will show in the demonstration. But as you can see from the screenshot, this is the checkbox that you can toggle to enable or disable split tunneling. Just to cover some of the steps here briefly, when you establish a VPN connection, first step is the client opens a connection to the VPN gateway. There's the authentication phase where there's the exchange of the username and password or a certificate. Then there's the negotiation of the IP address and what encryption to use. Then there's an exchange of routing information, and then the tunnel is established. So now we'll move on to some of the common challenges that you may have run into with some of the traditional types of VPN technologies. So first and foremost, they tend to be a bit complicated. So here's a screenshot of the OpenVPN client. I believe this is kind of an older screenshot. It might be a little bit cleaned up at this point, but a lot of VPN clients do still have the same types of complicated options. When you have so many options, it makes it difficult to figure out what is the correct combination of options, and especially for end users, it's a real challenge. You know, there's a lot of very technical terminology and interface type, protocol, authorization mode. So these are a lot of checkboxes, selections, and things that end users will really have a difficult time with when trying to configure. And as well, you'll notice this is just the basic tab. There's also an advanced tab. So it would be interesting to see what additional options might exist there. So I've sort of noted a few of the other kind of technical or ambiguous types of terms that I've seen with some of the other VPN clients, such as log verbosity or compression, protocol cipher, MTU size. So again, these are all very technically complex terminology, and the more options you have, the more difficult it is to just get all of the settings right so that the connection will actually work and stay connected. So those are some of the traditional, probably the most notable challenge with VPN is just the complexity. In addition, you have sort of the dysfunctional side of VPN where you get vague error reporting. So you see just kind of a funny picture there of error 800, but it is kind of true that a lot of the traditional error messages that end users would be exposed to are very ambiguous and don't really give any explanation as to what that error message might actually mean. You've got to do some Googling, and even then it will give you maybe a few suggestions that might be what's causing the problem. You might find that it disconnects and does not reconnect, or you may have challenges connecting from certain locations, whether it's a hotel, airport, Starbucks, and so forth. It might be slow to establish the connection or to transfer data. You might find that you can't browse devices, so even after you establish the connection, you still can't access the resources you need to. You might find that the VPN client, or rather the operating system that you need to use, isn't supported by the VPN client. So those are just some of the kind of dysfunctional challenges that face traditional VPN. The other big hurdle is the cost. A lot of times with other VPN solutions, VPN is a separately licensed feature. So, out of the box, it might have one or two basic VPN licenses, but to really get the full use for all of the users, you're ending up paying quite a bit of additional cost per user for VPN licensing. And in some cases, you might even need additional hardware, some other device that helps to enable virtual private networking. So now let's talk about Kerio Control's virtual private networking and how it overcomes a lot of those sort of traditional VPN type challenges. So first and foremost is the simplicity of Kerio Control's VPN. You've got pretty much everything is automatic. So whether it's the addressing of the VPN subnets, the exchange of the routing tables, any updates that might occur within the routing, and then the configuration of the traffic policies. There is a default setup that was pretty much designed to work right out of the box. So much of the VPN configuration within Kerio Control is done automatically. And so you see from the screenshot here, this is just a tunnel type, site-to-site type of connection. Just very basic parameters. Give it a name, define or provide the server address of the remote endpoint, and then click a button to detect the fingerprint of the SSL certificate on the remote side, and that's all you have to do. And Carsten will, of course, walk through this in his demonstration. And the same is true for the end users side. They don't have all these complex options to choose from. It's very straightforward. Again, a server name, and then the username and password. Very basic, simple options for end users. So stability is another important element of the VPN in Kerio Control. The fact that you can maintain a persistent connection, so it'll automatically reconnect if it's disconnected. And that's true whether it's the VPN client or a site-to-site type tunnel. You can have failovers, so you can define multiple VPN gateways. So if one is unavailable, it can switch over and attempt secondary. It's very NAT friendly. We built the VPN protocol from scratch based on UDP. So it's a socket-based, meaning it'll pretty much work in any NAT type implementation. So whether you're connecting from Starbucks or a hotel, airport, those types of scenarios I described previously that can be tricky when you're on a public network, those generally should work just fine through Kerio Control's virtual private networking. And it's available, the Kerio Control VPN client is available for a variety of operating systems, pretty much all the standard OSs for Mac, Windows, and Linux. And if you are on a mobile device, you can connect using just the native L2TP IPsec, and again, that's a very a pretty straightforward configuration, and Carsten can show that in the demonstration. So security, obviously, that's the main objective of virtual private networking, is to incorporate security. And so we can even add to that with a secondary form of verification, the two-step verification. So using a TOTP app on a smartphone, you can, as an administrator, you can enforce a secondary form of identification. And then the SSL that's used is using the latest SSL standards. And as you can see from the little screenshot there from the report of SSL Labs on our demo server that Carsten will show, it's our Mind Brewing server. You can see just a quick scan there, and it comes up with an A rating. So again, using the latest and greatest technologies for SSL. So one of the hurdles or challenges with traditional VPN, obviously, is the expense that's involved, and that's not the case with the VPN and Kerio Control. So it's a very important consideration that it's not separately licensed. So if you've got, for example, a 20-user license of Kerio Control, every one of those users is entitled to the VPN client. They can download it for free, install it, and connect up with their credentials. And there's no additional separate licensing for that. That VPN client is built into the standard user license that was purchased with Kerio Control. And if you're doing site-to-site tunneling, there are no restrictions whatsoever with the licensing. You can have as many VPN tunnels as you like. That's not tied to the licensing. So it is a very affordable implementation of VPN. Very functional as well. One of the downsides to traditional VPN, as I described in one of the previous slides, is the lack of browsing support. So you might be connected and you still can't access the resources you need to within the application that you're using. So service discovery forwarding enables that. So basically, if you're using any application that is based on Apple's Bonjour, which is common for like Apple TVs or printers, those applications that need to access those types of devices will work when connected remotely over VPN. If you're doing any kind of networking or accessing of file shares in Windows, the network neighborhood, for example, you can access those as well via the Microsoft NetBIOS protocol. And you can also access applications that use UPnP. So these are all protocols that are part of the service discovery forwarding in Kerio Control. So just to show you a brief kind of how service discovery forwarding works in action through an illustration, you see the image there of some devices on a network and a printer, and the megaphone sort of indicating the announcement of their name or their presence on the network, and then Kerio Control, because it resides on that network, is listening for those broadcasts, picking them up, and then retransmitting them to remote VPN clients, so that any applications that you're using remotely will work just the same as if you were on that same local area network. And that's all enabled via the service discovery forwarding feature. And of course, Carsten will show the service discovery forwarding and how you can enable that and configure it within the demonstration. So manageability is another important kind of differentiator with the virtual private networking of Kerio Control. If you want, you can configure alerts, so you can be notified if there's a change in the status. Maybe one of the tunnels might be down. You can receive an email notification about that. And then the monitoring and reporting. So activities that users commit over VPN, like accessing the internet through the VPN connection, all of that would be accumulated towards their statistics. But as well, you can see that in real time under the active hosts, as you can see from the screenshot there. I captured a screenshot of myself connected remotely, and you'll see I'm downloading some data, and you could see the real-time transfer of that. So getting some real-time activity monitoring or historical data over VPN activity is a pretty significant management addition or component of virtual private networking and Kerio Control. Flexibility, so the ability to assign additional policies on top of VPN clients. So, for example, quality of service, restricting or guaranteeing bandwidth for VPN tunnels, or as well applying transfer quotas to authenticated users. So whether a user is connected on the local network or whether they're connected remotely by VPN, any quotas you assign to that user will be factored in both scenarios, whether they're connected locally or remotely. And then any policies you've set up, whether they're content rules or traffic rules, assuming you've disabled split tunneling, so you're forcing VPN clients to connect through the gateway internet connection. Any of these types of policies that you've set up, like the example here in the screenshot, where you're filtering out certain web categories like hacking or malware, those filters would also apply to VPN clients as well. So just a quick summary of how Kerio Control VPN resolves some of the traditional VPN challenges. You have, with the traditional VPN, the complication of configuration, whereas Kerio Control's VPN, pretty much everything is done automatically, so it's very easy to configure. With traditional VPN, you might have problems connecting from some locations, such as airports, hotels, and so forth, any kind of public network, whereas the protocol that we designed within Kerio Control's VPN is very flexible and works pretty much from any location because of the fact that it's very NAT friendly. Traditional VPN sometimes can be difficult to troubleshoot. You get vague error messages. It may not be very reliable. If the tunnel goes down, you might have to manually reestablish it. Whereas Kerio Control's VPN always is very aggressive to try and maintain a persistent connection or to fail over if you do have the failover gateway configured. Traditional VPN, oftentimes you have additional licensing for using virtual private networking, whereas VPN in Kerio Control is a bundled component, so you don't need to pay for additional licensing to use VPN in Kerio Control. In traditional VPN, you may not be able to browse devices, whereas with the service discovery forwarding feature, those applications will work whether you're local or remote. And then the last point is the limited management that you might have in traditional VPN implementations. And with Kerio Control, you do have those items, the ability to manage bandwidth of VPN and to control access policies for traffic rules. So at this point, I'll go ahead and hand it over to Carsten, who will do a demonstration and show you in action a lot of the features that I was previously describing.
Okay, good. So I switch over to the demo screen. I'm going to share my screen. So sharing, and I think, and maybe Brian, you can confirm it, you should now see the interfaces part section of the Kerio administration of Kerio Control.
That's correct.
Perfect.
Yes.
Perfect. Cool. So, first of all, I'm going to show you about the VPN interfaces configuration. So you just navigate in the web administration to interfaces, and here you have a section which is called IPsec and Kerio VPN interfaces, and you already have the VPN server here. You just do a double click on it, and now there are some things you should control. First of all, if you would like also to have mobile devices connected to your Kerio Control, or maybe a system where, as we are having the Kerio VPN client for Mac OS, for Windows and Linux, but normally mobile devices use the IPsec and it's already integrated in the mobile devices, you need to tick the box Enable IPsec VPN Server. Of course, we also would like to connect to this Kerio Control with our native Kerio Control VPN client, so you also need to tick the box Enable Kerio VPN Server. Then you just check if there are valid data in the VPN Network and Mask section, which brings us directly to the next part. So here you see the tabs first for the IPsec VPN. In certificate, you just choose one of the certificates you have maybe created or imported to your Kerio Control. You can tick the box that the clients should use this certificate. Next part is that you are ticking the box for use pre-shared key, and you're defining a pre-shared key here, which is some sort of password you are going to use, for example, top secret or something like that. Of course, not top secret, but maybe something more complicated. Then you tick the Enable MS-CHAP v2 authentication, and that's it for the IPsec VPN section. Next is the Kerio VPN section. Again, you choose here the certificate for which is dedicated for your VPN connection. There's nothing to change here and nothing to change here on the listen on part. And this is a part Brian was talking about. If you would like to have your remotely connected users using the internet, the normal www, also through your Kerio Control, then you have to tick the box here. That means that all the internet traffic is going through your Kerio Control, also for the remotely connected users. Per default, this box is not ticked. In most of the cases, it makes more sense to let this box unticked, so people which are remotely VPN into your local network use for ordinary surfing and stuff like that their own internet connection directly. On the DNS part, again, nothing you need to change on that part. Also on the WINS part, nothing you need to change there. So as you can see, it's basically just ticking some boxes, choosing a certificate, defining a password, that's it. I just say OK. Now I need to say also apply. And that's it for this part. Now I'm going to switch over to the traffic rules. As Brian already mentioned, the appropriate traffic rules are created automatically for you, but it is just to show you what you can review. So basically there are three rules. The first one is, of course, the VPN services rule. This shows, or that means that from any source, it goes to the firewall and should apply to the services IPsec and Kerio VPN. And of course, you should allow this. The next rule, again, automatically created, is the Internet Access Rule and NAT. This is interesting if you tick the box that all the internet traffic from your remotely connected users should go via your Kerio Control. Of course, then you need a specific rule here that the traffic from the VPN clients also going to the internet interfaces, and of course it needs to be allowed. This is necessary if you're not using split tunneling. The last rule is the local traffic rule, which basically means that everything from the firewall, trusted local interfaces, VPN clients, and VPN tunnels should also be, as a destination, go to the firewall, VPN, all VPN, trusted local interface, and of course it should be allowed. Next thing, after we have created the VPN server itself, we of course need to allow our users that they are allowed to connect via Kerio VPN. And we go here to our VPN test user, and in the template which is created on this machine, normally the newly created users do not have the right to access this machine or this Kerio Control via VPN. This is why I have ticked here, this user has a separate configuration. When I now go here to the rights tab, you can see that you just need to tick the box, user can connect using VPN. That's it for this user. You can also create a template. For example, this template here I created, it's a newly created one. I have already ticked the box, user can connect using VPN, which means that every user which is newly created and already created based on that template will have access to the Kerio VPN services. And Brian was already talking about the service discovery forwarding. We just find it here in the security settings on the tab 0 configuration networking. By default, it is not ticked. You just tick it here, tick the box enable service discovery forwarding. Then you need to tick, and this is important, the box the LAN, which means your local area network, and of course the Kerio Control VPN clients. If you have, for example, a Plex media server or a NAS or whatever, providing media in the remote network, for this can be interesting that you enable the UPnP services. That's pretty much everything on this side. What I now want to show you, before I show you our Kerio Connect VPN client and the IPsec configuration, is how you can create a site-to-site network tunneling. Yes. As you can see, we have no tunnel here. As it is also in real life, you always have an active and you have a passive part. So I just start to create a VPN tunnel, and here is the first thing you can choose if you would like to have this Kerio Control the active or the passive part. I've chosen to be for this Kerio Control that should be the active part. What it is going to do, it is going to do the active tunnel to demo Kerio Control. As I said, it is the active part. Now I just fill in the credentials or the DNS or the IP of the opposite Kerio Control. In our case, it is demo.kerio, control.demo.kerio.com. Nothing to do here. This is a local ID. I go here to Kerio VPN, and now I just click on Detect Remote Certificate, and it talks to the opposite Kerio Control and presents me the certificate of the remote of the other Kerio Control. As you can see here, it's our demo one. I say accept this certificate. What you just need here is to copy the local endpoints SSL certificate fingerprint. I just say OK here, because as I said, I just created before already the passive part of this tunnel. This is our demo Kerio Control. As I said, I have here ticked enable this tunnel again. This should be the passive part, and I'm just filling in the SSL certificate fingerprint of the active Kerio Control, which should connect to this one. And I just say OK. I will say apply, and as you can see, the tunnel is up and running. Now I switch back to my Kerio Control on bind brewing. So now we have a tunnel to tunnel. We have a tunnel connection, a site to site tunnel between two Kerio Controls. Now I show you how you can establish with the Kerio VPN client a connection to your Kerio Control. You just navigate to our homepage in the section support of Kerio Control. You can download the Kerio VPN client for your operating system. Again, we have it for Mac OS X, we have it for Linux, and we have it for Windows. I'm showing it here on my OS X system, and I need to apologize that it is in German, but of course, if you are using this on your, let's say, English operating system, this will talk English to you. So what I'm going to do is I just define a name for the Kerio Control I would like to connect to. Now I go here, vpn.winebrewing.com. I use the user I've just created, and I use a pretty secret password. It looks for the certificate and it says connected. And to prove that I'm not cheating, later I go here to the VPN clients, and as you can see, the VPN test user is connected to this Kerio Control. You can see the operating system, you can see the host name from the connection, and you can see that it is connected and how long it is already logged in. That's it for a Kerio VPN client. You see, it's that simple. You just need to have the server's name, DNS name or IP. You need your username and you need your password. That's it. Now I'm trying to show you the same on a mobile device. And what I'm using here is an iPhone. I will just unlock the screen, and I hope you can see everything when I'm monitoring it on my computer. So let's say mirroring, done. So if you're going to create a VPN connection on your iPhone, and it should be pretty the same on an Android device, for example, you go to settings. And as you can see, I have already here an entry which is named VPN. On an iPhone, if you never ever created a VPN connection before, this topic here in the settings is not showing up. Then you just need to go to General, scroll down a little bit, and then you have VPN. Once you have created such a VPN connection, you will find the VPN logo and the VPN entry directly in the highest settings. So I just go here, I say add VPN connection. First of all, I need to use the type, and I will go for L2TP. Now I need to write a description. I just write bind. Now I need to enter the VPN server I'm connecting to, and this is our winebrewing.com. The account is the VPN test user. We have a very secret password. Even if you note it down now, this user will be deleted right after this presentation. And again, I enter the pre-shared key and I say done. Go over here. I'm trying to connect. And now I keep my fingers crossed that it is working. Takes a little bit. And as you can see, status is connected. And again, just to show you that I'm not spoofing, here you can see the VPN test user is connected via IPsec. The operating system can not be detected via IPsec, but as you can see, it is connected. So I just switch over here again to the administration, and as I said to you, I will remove this VPN test user immediately. So even if you have noted down the password now, you will not be able to use it. So that's from my side. I will stop sharing now and will hand over to Brian again. if there are some questions.
Thanks, Carsten.
This is a good question, Jürgen. Is there an app for the iPhone, or is it just the standard VPN for iOS? As I showed you during the demonstration via my iPhone, it's the standard VPN, integrated VPN in the iOS operating system.
And just to point out, you can also use Android and other smartphones that support the L2TP IPsec option.
There's a good thing. I expect you need to assign a different IP range on each control box if you are using site-to-site VPN. Brian, would you like to just give the example we had earlier this day when we were creating it?
Well, so yeah, John is definitely right. That is a very important consideration. You want to make sure that all of the local subnets are unique, that you don't have two sites connecting to each other with overlapping subnets. There is also a different kind of a hidden or automatically assigned subnet that in rare scenarios you might need to update. And coincidentally, when we were preparing for this demo, we ran into that circumstance that the VPN subnet that is automatically configured by Kerio Control, it's a 172.168. Unfortunately, I don't have it in the screenshot here, but Carsten showed it. When you edit the VPN interface, there is a subnet that's automatically generated for VPN routing. You'll just want to make sure that that is unique. Again, it's like a 172.16. something, and I'm not sure exactly how Kerio Control ensures that those are random. It does have some kind of built-in method for doing that, but in general, there's about probably, I don't know, several thousand different combinations. So most likely you probably won't have any conflicting subnets there, but it is another thing you'll want to look out for, just to make sure that not only your local IP subnets that you've configured on internal interfaces, that those are unique from opposing networks, but that the virtual private network subnet that's auto-generated by control, you want to make sure that that's also unique. But again, they should be, but there is a slight chance that they might be in conflict. So, how do you update the built-in certificates when they expire? So we didn't show that during the demonstration, but there is a SSL certificates configuration section within Kerio Control, and from there you can import new SSL certificates. So usually you would have to, if it's a signed cert, you'd have to go through the certificate authority to have them sign another certificate and import that new certificate. Depending on the provider, they might have a different process for how you go about renewing a signed SSL certificate. Otherwise, if it's a self-signed cert, there's a built-in local authority and control where you can just generate a new SSL cert. Of course, if you're doing your own SSL certificates, you can span it out to, I think, 10 years at least. So it's not a very regular operation where you would have to update that. But once you get a new SSL certificate imported, you might want to give it a different label, and then you can go into the VPN server configuration that Carsten showed in the demo, and then associate it to the new SSL certificate that you've imported.
What I have forgotten to show you is if you have any questions around the VPN functionality in Kerio Control, I would just like to recommend you navigating your browser to kb.kerio.com, which brings you to our knowledge base. When you just type into the search field VPN, all the articles which belong to the VPN functionality of Kerio Control will show up, and you will then there have screenshots and step-by-step configurations.